Hi, in this session we will consider the next category of problems in which we will consider a cylinder of base diameter 60 mm and height 70 mm and it is resting on HP on its base, and here we have a thread attached to the base and the other end of the thread is attached to the top point, and you have to draw the shortest length possible for achieving this condition. And here first of all you have to draw the development of the cylinder. First of all draw the plan and you have to mark the points, and after that project upwards and obtain the elevation, and after obtaining the elevation you have to draw horizontal projectiles from the top surface. Place the first set square like this and draw a horizontal projector like this. So here I have already drawn that projector, and after that you have to draw the first seam line. So here we are drawing the first seam line, and that seam line is our generator AI. This marked like this. This is A and this is I. A is located at the base portion, and after that you have to find the stretch out length, and that is calculated using this formula, and it is around 188.5 mm. You take that distance and mark the second point somewhere here. This distance is equal to 188.5 mm, and after that you have to place your set square like this. Place your set square like this and draw a vertical line from that 188.5 mm point, and it will meet the top projector at a point, and this line marks the second seam line, that is also AI. After that you have to divide this 188.5 mm line into 8 equal divisions. That is already done here, and you have, after that you have to name the points. This is point B, this is point C, point D, point E, this is F, this is G, and this is H. And similarly at the top portion you have to mark the points, and you are marking this is I, this is J, this is K, L, M, N, O, and P. So we have obtained the development of the cylinder given in the problem, and after that you have to consider the thread. The thread is attached to the base point A and the other end of the thread is attached to the point which is located directly above the first point, that is point I, and first end is attached here and the other end is attached here, but the thread has to complete one revolution around the object. So how can you achieve that? For achieving that, you have to connect A and I in the development. Connecting this by means of a thin line. So this thin line represents the thread. Here it is starting from point A and it is moving along the lateral surface and ultimately it is reaching point I, which is located directly above point A. After this, after drawing the thread, you have to show the corresponding positions in the elevation. For that, you are marking the intersecting points. This thread is intersecting generator BJ at this point, that is point 1. It is intersecting CK here, that is point 2. This is point 3. This is point 4, 5, 6 and 7. We have 7 points. These are the points located in the development, and we have to mark the corresponding positions from point 1 to 7 in the elevation, so that will mark the position of the thread in the elevation. For that, you have to draw horizontal projectiles from these points. Let us draw the projectiles. Placing the set square like this. How to draw parallel lines. So second set square is placed like this. After that, I am sliding along the second set square and drawing projectiles. We will extend it later. We have to extend these lines. So we have obtained the projectiles. Now, this is the projector drawn from point 1, and point 1 is located on BJ, and this is B dash J dash. So this must be point 1 dash. Similarly, point 2 is located on CK. This is the projector, and this is C dash K dash. So you can mark the position of point 2 dash point 3 is located on DL, and this is the corresponding position in the elevation, that is point 3 dash. Then point 4 is located on EM. This is E dash M dash, and this is the projector, and this must be point 4 dash. Then 5 dash will be here. 6 dash will be on GO, that is here 6 dash, and here we have 7 dash. So these are the points. After that, after obtaining the points, you have to connect these points by means of a smooth curve. And here the curve must be dotted line because it is located in the rear portion of the cylinder. So this is the final position of the thread in the elevation. This must be dotted lines, and it must be a smooth continuous curve, and that is the solution of this problem. Here you can mark the thread length by measuring this distance. It is around 202 mm. Length of the thread is equal to, and measure this distance. It is approximately 202 mm. That must be marked here, 202 mm. You have to place this result in a box, and that is the solution of this problem. Thank you.